Let's explore some of the properties of linear equations. First, the general form of a linear equation is y equals ax plus b, where a is our slope, telling us the steepness of a line, and b is our y-intercept, telling us the value where the graph crosses the y-axis. X will always be our independent variable, and y will be our dependent variable. Look at some of the following equations. Do you think you can recognize which one of these are linear? Are more than one of these linear? In fact, these are all linear. It might be helpful to pause the video here and evaluate these a little more carefully. When a problem asks us to evaluate a linear equation, we are being asked to find the ordered pair that corresponds with the given x value. For instance, if we're given the equation 14x minus 7y equals 21 and told to evaluate the function at x equals 8, first, we should take the original equation, plug in our x value, and simplify. We're able to find that the y value that corresponds to x equals 8 equals 13. So, the ordered pair that satisfies this question is 8, 13. We may encounter a number of different graphs of linear equations. Remember, graphs of linear equations are always going to be straight lines. This is very helpful to recall. All points on the line of a linear equation can be generated by the equation in the form y equals ax plus b. There are three types of graphs depending on what value of a we're working with. Remember, a is our slope. If a is greater than 0, we're dealing with a positive slope, which means the line slopes upward to the right. If a equals 0, we're dealing with a graph with no slope. This means the line is horizontal. Finally, if a is less than 0, we're dealing with a negative slope, and the graph of the line will slope upward to the left. Let's look at some examples. For the equation y equals 4x plus 13, we recognize that 4 is our slope, and in this case it's positive. Further, we recognize that 13 is our y-intercept. So, the graph of this equation will look something like this, with a positive slope of 4 and an intercept of 13. In another equation, y equals negative 1/2 x minus 4. We recognize that negative 1/2 is our slope and it's negative. Further, we recognize that negative 4 is our y-intercept. So the graph will look something like this, with a negative slope sloping upward to the left or downward to the right, and intercepting the y-axis at negative 4. Now this is an interesting equation, y equals negative 6. I'm sure it stood out to you that there is in fact no x term. Think of this as there being a 0 coefficient on x, so our slope is 0. In this case, we're working with a horizontal line at y equals negative 6. Finally, how about the equation x equals 13? We can think of it as similar to the previous equation in the sense that we're working with one variable equaling a number. However, in this case, our variable is x. This means the graph x equals 13 will be a no slope vertical line at x equals 13. Observe that a vertical line is known as having no slope. There are many applications of linear equations in real life. For an example, John the plumber charges his customers $25 for a house visit and $10 for each hour he works at their houses. A linear equation that expresses how much John earns for each job is y equals 10x plus 25. What are the dependent and independent variables? What is the y-intercept? And what is the slope? First, let's try to understand the dependent and independent variables. In this equation, the independent variable, x, would be the number of hours that John is at a customer's house. This value is not dependent on anything else. On the other hand, our dependent variable, y, is the total amount in dollars that John charges his customers. This depends on how many hours he works at their house. Let's now look for the y-intercept and the slope. Again, returning to the equation given in the problem, y equals 10x plus 25, we can recognize that our y-intercept should be 25 and our slope should be 10. Remember, our y-intercept of the equation, 25, should be the flat fee that John charges for a house visit. It's, in considering this, the starting point of the equation. The slope, 10, is the amount in dollars that John charges per hour at a house. In another example, Alex earns $10 in allowance each month and $2 additional for every chore she does. Let's write an equation for her monthly allowance and then find the dependent and independent variables. First, let's write an equation. We're initially told that Alex earns $10 each month. She gets this no matter what. It's similar to a flat fee. This is where she starts, so we recognize that this $10 is our y-intercept. Next, we're told that she earns $2 additional for every chore that she does. This amount is dependent on the number of chores, and we can consider this as multiplying the number of chores by 2. So, we recognize this as the slope. Now, based on this equation, we can recognize that the y-intercept should be 10, and the slope should be 2. Filling these into the formula, we're given the equation y equals 2x plus 10. Our independent variable of y equals 2x plus 10 will be the number of chores that Alex does in a month. This number is not dependent on anything else. Our dependent variable is the total amount in dollars that Alex earns for a month, and this depends on how many chores she does. Let's review what we've learned. So for linear equations, our form will always be y equals ax plus b. This is a helpful way to recognize which equations are linear. In this equation, a is our slope, b is our y-intercept, x is our independent variable, and y is our dependent variable. One other important thing to remember is that the graph of a linear equation is always a straight line.